Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Coming to you from the studios of VK3 CSJ in Narre Warren South. We're broadcasting tonight on the prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater, VK3 RTV Channel 1, digital channel HD, full HD, and also streaming on YouTube, which hopefully will hang in there for the hour tonight. I still have flaky internet problems here with the internet dropping out, so I'm hoping that over this weekend that might get sorted out, but that's another story. Anyway, good evening to everybody. I trust that all is well and that your footy team is winning. Anyway, tonight's going to be a bit of a special night tonight in respect to the fact that I'm going to play a episode from the astrophys.com website. It actually will run for about the full 50 odd minutes, but it's an interesting interview with that Brendan O'Brien has done just recently with a Dr. Laura Drezian. I think that's how you pronounce her surname, Dryerson, titled Radio Stars. And as Brendan says here, he says that I'm really excited to be speaking again with Dr. Laura Dryerson, who is now recognised as one of Australia's superstars of STEM. And he says here that we first met Laura 5 years ago, back in 2018, when she was doing her PhD at the University of Manchester at Jodrell Bank. Laura's backstory is all there in Astrophys episode 54, so I'm going to have to catch up with that one, and we'll do a kind of a backward feature on that one. Go back to episode 54. But anyway, the continues on here to saying that you heard about her obsession with space starting at age 4 and her natural yet meandering academic astro journey up to the point where she was using commensal searches on the Meerkat array in South Africa for pinpointing and localization of FRB's fast radio bursts. Today we're taking up the story from where she left off, and here for the first postdoc with the CSIRO in Perth and her FRB and radio stars research, and her outreach work in the outback with Indigenous school kids who live near the iconic Murchison Wide Field Array and the ASCAP Array. Continues on to say that Laura tells us about her current research and her work as the joint science lead on the VAST project, and you will love the clarity of her description of the power and nature of commensal searches and how she uses archival data to verify that her radio data is actually coming from her targeted star and not from a radio galaxy hiding behind it. That sounds a bit familiar. Another gift Laura gives us is her brilliant explanation of how scientists establish and maintain collaborations, both big and small, and how scientists often begin with a large number of hypotheses to explain observed phenomena, and how the null hypothesis is such a powerful tool in developing an accurate understanding of our universe. So I shall almost go straight into that, but before I do, I shall do the usual introduction about the society first. Before I go into the transcript. No, into the sound file. Thanks to Brendan too for allowing me to download that at the last minute. Usually his files are not downloadable. He doesn't make that available. but I was going to run the sound file direct from the website live, download as it goes. But the only risk there is that the internet would fall over halfway through the playback and would screw things right up. So we managed to download the file just in time. So thank you, Brendan, for allowing me that access just now. All right. Now, just bring up something here. Not that one. Where are we with that? There it is. Okay. vMix. It's an interesting program. You got to get your head around how to use it. All right. The Astronomical Society of Victoria, which is this broadcast is on behalf of, and has been since 1988, thanks to Russell Ward, who did the first 20 years of it. And g'day, Russell, if you're listening tonight. Yes, we also have a Discord channel I forgot to mention. If you want to come up on Discord, it is running at the moment. So we've already got a few folks there. Martin, VK7JAH in Launceston, Cassiopeia, Graham, GRK in Bendigo is listening. G'day Remus, VK3VRS Richard, and Steve, VK3SPX in just outside Ballarat, and Dave from VK3KDM from the Mount Burnett Observatory is also listening in tonight. So I do hope that you find tonight's interview of great interest. And we also have an email address if you wish to send a signal report off to vk3ekh@gmail.com, vk3ekh@gmail.com. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for this study among its members. Monthly meetings are usually held on the second Wednesday of each month except in January, the latter being held on a Saturday night. Meetings start at 8 p.m. at the Morley Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory, receipt of the ASV magazine Crux, containing news and articles and observing notes and stories and interesting things from members of the Society, and the free provision of the Astronomical Yearbook, kind of like an almanac, which is published by the ASV annually. Quite a decent publication. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector, the 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed in the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan to members so that they can try before they buy. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two only with appropriate training. These range from 300mm to 1000mm in aperture. There's also a radio telescope on the site. It's an 8.5 metre fully steerable telescope, which members can access with involvement with the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet and radio astronomy, computing, cosmology and astrophysics. Historical studies, research and astronomy in general are all catered for. Contact details for various section directors are provided in the yearbook, but if you don't have the yearbook, the further information may be obtained by visiting the ASV website at www.asv.org.au. That's www.asv.org.au. Further information, yes, just said that. And of course, there's a regular Crux extra bulletins sent out via email to members every other week. You can also write to the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001, if you wish to write a letter, which I don't think anybody does anymore. Okay then, alrighty. What about the ATV? Oh, okay. Right, how's that? All right, now, astrophiz.com is the website for Brendan O'Brien's amazing collection of audio files. He now has 171. It was the quick count that I saw. 171 episodes now available to listen to, and most are from professional astronomers, radio astronomers and physicists that are all up and coming in their fields, and he's managed to get a hold of these folks and do very interesting interviews with, and allows them to open up and talk about their field of interest. What's the word? Unhinged? No, something like that. In fact, I think the first episode was with our Robert Arrowsmith, who was former section director for the radio astronomy section at ASV before or after me. And there's also, I think, a little interview with me in there somewhere as well on one little obscure episode. But nevertheless, let's just bring up a caption there with the website, and I'll just run a couple of links there if I can just bring those up quickly. There's the website for astrophiz.com on the vision side of it, and also Brendan's Facebook page, www.facebook.com/astrophiz, ASTROPHIZ. So yes, you can get lost in his website for many hours. So there it is. All right, I've already run over time. I can see that. So I'm going to go across to our interview tonight, and let's just hope this all comes across without too many issues. Where's our audio file? There it is. Okay, that's ready to go, and it's ready to go, and the caption's up on the screen. Let's see how we go with this, and I'll call the microphone. So this is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, going across to the interview with Dr. Laura Dryison, and her discussion tonight is called Radio Stars. And I'll just get rid of that there too, and I'll bring up that one there. All right. Yep. Let's see if this works. Stand by. Where is it? There it is. Get rid of that. Tick. There's just a few things all happening here at once.
Welcome to the Astrophiz podcasts. My name is Brendan O'Brien, and we'd like to acknowledge Australia's first astronomers, the Aboriginal and Torres Strait Islander people, the traditional owners and custodians of the land we are on. This episode is produced on Yorta Yorta and Gadigal land, and we're asking you to influence your local politicians with the message that we really need to change our energy policies and move to renewable energy sources to mitigate the effects of climate change, and each month we love bringing you 2 fabulous episodes. On the first of each month, our friend, molecular pharmacologist, toxicologist and amateur astronomer, Dr. Ian Astroblog Musgrave, brings you his monthly sky guide with all the essential observational highlights for telescopers, astrophotographers and naked eye observers. Each month, Ian also includes Ian's Tangent, where he takes us on a short journey of astronomical wonder. In the middle of each month, we bring you an exclusive and in-depth interview with a noted astrophysicist, astronomer, particle physicist, radio telescope engineer, data scientist or space scientist. So right now we're going to zoom up to Sydney, Australia to meet a wonderful astrophysicist who you first met 5 years ago when she was completing her PhD at Jodrell Bank, and now she's back in Australia into her second postdoc doing more beautiful research into transients and radio stars, and she has some great stories you'll really love. So hey, let's catch up right now with Dr. Laura Dreesen. Hello again, Laura.
Hi, Brendan. How are you?
Very well, thanks. And I'm really excited to be speaking with Dr. Laura Dreesen again. We first met her 5 years ago, back in 2018, when she was doing her PhD at the University of Manchester and working at Jodrell Bank. Since then, she's done more travels and more fabulous research, and now she's back over in Australia's east coast at Sydney. First up, Laura, congratulations on winning your doctorate, Dr. Laura, and for recently being awarded as one of Australia's superstars of STEM. And thanks for speaking with us again today, Laura.
Thanks, Brendan. I was really excited to get your email because the last time we chatted was the very beginning, only a couple of months into my PhD. So lots of things have changed since then, and I'm excited to chat.
I can imagine. Okay, so before we talk about those recent adventures and your research discoveries, we'll remind our listeners that Laura's backstory is all there in Astrophysics episode 54 from March 2018, and we heard about her obsession with space starting at age 4 and her natural yet meandering academic astro journey up to the point where she was at Jodrell Bank, and for her PhD at Manchester, she was using commensal searches on the Meerkat array in South Africa for pinpointing and localisation of FRBs, fast radio bursts. So today, we're taking up that story from where we left off, and I can't wait to hear it all. So, Laura, can you tell us about Dr. Dreesen's first postdoc position with Australia's premier science organisation, the CSIRO, and your move back to warmer climes? How did you land that position, and where were you based? Who did you work with, and what research did you focus on over there in Perth?
We probably have to go a little bit into the PhD as a sort of start of the story of how I ended up at CSIRO. So where we left off is that I just started my PhD and I was working on localizing FRBs, and I did keep working on that. But in the meantime as well, Professor Ben Stappers, who was my PhD supervisor, managed to convince me that radio stars were also something interesting to look into. And I have to say that it took a little bit of convincing. As a radio astronomer, we don't typically think about stars at all. You've interviewed quite a few radio astronomers, and we tend to look at, explosions, supernovae, X-ray binaries, black holes, galaxies, and stars don't typically make the list. So when Ben first said, let's have a look at stars, I sort of went, oh yeah, sure, radio stars. But eventually I came around because it turns out they're really interesting and nobody's really looked into them in detail since about the 80s or 90s. Because of these commensal searches we can do now, they've sort of come back into fashion a little bit. Mainly because it was hard before with the telescopes we have that can only see a small bit of the sky to say, hey, give me 20 hours to point at this star and maybe we'll see nothing at all. That's not particularly convincing when you're asking for telescope time.
Yep.
But now we have Meerkat, ASCAP, all those telescopes that can see a big chunk of sky. So I can take the data on stars that just happen to be in the image. So nobody was pointing at them, but they're there anyway. So I can grab that information. So it's really had a big leap in stellar radio astronomy. And that's really how I ended up at CSIRO. They posted a job and I sort of went, actually, that's pretty much like that job description was written for me, because it was to look at radio stars and investigate how radio emission from stars might affect the planets that might be orbiting those stars. So I went, oh, it's in Australia, even better. Since the pandemic, plans change, and I thought maybe being in Australia for a little bit wouldn't hurt. And I went over there to Perth 4 weeks before the Melbourne Football Club Grand Final, and I have to say that I sat in the front row behind the goals because it was just excellent timing, being a diehard Melbourne supporter. So that was pretty good. So I was over there in Perth and working on radio stars, but still working on FRBs as well, because I can't help it. They're pretty cool.
Fantastic. Yay, demons. Okay, so you're over there in Perth and you're obviously not far, or 300 or 400 kilometres away from ASCAP and the Murchison Wide Field Array. Did you do some work on ASCAP, and did you get out to see any of those beautiful radio telescopes in remote Western Australia?
Yes, I'm very lucky that I switched a little bit from Meerkat to ASCAP coming over to Australia, which makes sense since it is our very own Australian SKA Pathfinder telescope out there in the Murchison, about 8 hours drive from Perth or 4 hours from Geraldton, if you're familiar with that part of the world.
Yep.
Out into the fair dinkum outback of Australia, the middle of nowhere in the truest sense. So yes, I've switched a little bit. Well, I work a bit on both, but to ASCAP, searching for these stars, and also as part of the VAST collaboration, which I think we'll talk about in a little bit. And yes, I was incredibly lucky to go out to see the telescopes. I was invited by Dr. Rob Hollow, who's the CSIRO education and outreach person, who goes out there about once a year, pandemic allowing, to share our science with the remote school in the Murchison. So that's really exciting for us because we use those telescopes out there in the Murchison at Inyarimana Ilgari Bundara, the CSIRO's Murchison Radio Astronomy Observatory. And it really means a lot to us to be able to give back to the community and say, this is what we're doing with these amazing telescopes. So I got to go out there and spend a day with the amazing school kids out there at the remote school, and talk about the stars that I find and how I find them, and get to see the telescope. So not many of us get the privilege to go and take photos of ASCAP, but I was lucky enough to get to do that as part of sharing that with the community out there.
Oh, wow, fantastic. And those kids would be blown away by seeing scientists and lady scientists and hearing what's happening on their own land. That's beautiful. You mentioned the VAST project. Now, we have just mentioned VAST about 5 episodes ago. Can you give us a skinny on the VAST project? You're the joint project scientist, so perhaps you could introduce our listeners to the VAST project, its purpose, its methodology, and tell us about your VAST responsibilities. And how's it all going, Laura?
It's going great. I'm happy to report so far. We've really only started doing the full survey, so exciting times in the future. But VAST is the Variables and Slow Transients Survey with ASCAP. I'd probably rename it something else. Slow Transients just doesn't sound quite so fun as what we're doing, does it? So we'll just call it VAST instead. It's a project to commensally, so we've used that word a few times, and that basically means looking at all the sources that we see with our telescope, rather than just pointing the telescope at one usually really cool thing. We're just pointing at the sky to see what we can see. And we have our own observations where we choose where we point the telescope, as well as just taking any observation with ASCAP. The beautiful thing about ASCAP is that all the data are publicly available as soon as possible. So that means that we have agreed with the other teams that we get to have a look, but also we can just grab the data as it comes out and see what we see in there. But the main purpose of the VAST survey is to do roughly 15-minute observations and just repoint to the same part of the sky over different times. So there's parts of the sky that every 2 weeks we grab a 15-minute snapshot of. And there are other parts of the sky that, we might wait a couple of months to have another look. And it'll go over, I think it's 4 or 5 years. I should know that off the top of my head. That we'll just keep looking at parts of the sky with no particular object. We're not saying we'll look at that spot because there's this particular thing there. We're just going, that's a patch of sky, and we're going to see what changes over time. So the purpose is to see anything that suddenly comes into existence and becomes booming and bright, or things that change in brightness over time, things that maybe disappear. So we're looking for the things that change in the radio sky on all sorts of timescales. From the shortest, we can do 10 seconds is the shortest image we can make, up to the full few years of the observation. So we're looking for things that change. And as part of being joint project scientists with Dr. Dougal Dobie, who's at Swinburne, it's sort of to have an overview of what everybody's doing. So we're really only ramping up now, and most of my duties sort of involve organizing the monthly meetings so that we can keep track of what everybody's doing and the exciting things that are coming out. But as things ramp up and as we start doing all of our observations, which, as I said, we only really started doing part of the full thing a couple of months ago, we're going to start having people coming forward and proposing things that they want to do with our data. And it's going to be my job to keep track of what everybody's doing and making sure we're all working together nicely. We don't have 10 people trying to work on the same thing, and we actually get those 10 people working together instead.
Fantastic. Now, this is quite accidental. That's a lovely segue into the next question I've got for you, Laura. So, career astrophysicists like you contribute to a great number of different collaborations all over the globe, and that's how most big science is done. And really, no one's hoping for some lone genius beavering away in a lab somewhere to come up with a next big scientific discovery. Now, as you've just alluded to, we know that many early career astronomers listen to our episodes. So for them, can you tell us how scientific collaborations are formed? How do the scientists come together to join and propose and contribute to collaboration? So how do you all share and organise that data, your analyses? I hope you don't use email. Is it all tied up with funding?
Yeah, so collaborations are really a key part of what we do. And as you say, none of us are really sitting in isolation just doing science. It just wouldn't work because I don't have that humongous skill set. I really need other people to help me out so we can actually get to the goal that we're trying to achieve. So we definitely aren't sitting all alone, and less so even now that the pandemic is it looks a little bit different, let's say, to how it did a couple of years ago, where a lot of us were sitting alone, not by choice. But we're all connected still, and lots of Zoom meetings, and Slack is really our main method of sort of quick collaboration chats. I think, interestingly, in radio astronomy, just from what I've observed, I haven't set up any big collaborations myself, but just from what I see, collaborations in radio astronomy tend to be around the telescopes that we use. So someone will be part of setting up a telescope, say 10 years before the telescope is even built, and they'll work out, what are the specs of that telescope? What is it going to be able to see? Have some ideas about the science that can be done. And then they'll gather some people together. Usually it's a couple of senior astronomers who get together with a vision of what they can do with the telescope. And then they start building that collaboration, adding postdocs, other senior scientists, bringing their PhD students in. So when the telescope is ready to go, they're ready to use the telescope to achieve that hopefully big goal that they've thought about. So a lot of the big collaborations, at least in radio astronomy, are focused around the telescope. So VAST is one example. The Thundercat team, which I'm in for Meerkat, which is sort of a similar thing, but not quite the same as VAST, also doing commensal searches and investigations of image plane radio sources.
Yep. So
I think just from what I've observed, it's typically one of the ways is around telescopes. But of course, the other way is if, again, a nice senior astronomer gets a big pot of money, they start to build their own team, again, around a specific science goal, and they get that team working together. So that's like MEERTRAP, the More Transients and Pulsars team that I was in. led by Professor Ben Stappers. He got an ERC Horizons 2020 grant and then built a team around that. Yep. But there's also the other nice way, which I think is sort of a serendipitous scientific collaboration, where you might have a Zoom chat or a conference, or you just meet up someone at the university and you start to have a chat and you go, oh my goodness, we could do something really cool together. And those tend to be sort of a little bit maybe smaller collaborations, but those can be really fun, where you've just realized that you could do something really cool and interesting together. And I think those are also nice because they often bridge the gap between different types of astronomy. Rather than having a big group of radio astronomers, which is fantastic, you want to have the other option where you actually might chat with an optical astronomer or someone who's maybe a physicist or something like that, to maybe a little bit of a smaller goal, maybe 1 or 2 papers instead of a big 5-year collaboration. But those are also really fun to make that connection sort of in real life, rather than a big planned thing. So there's a few different ways, and I think it's good to keep an eye out for all of those different ways. And don't be afraid to join collaborations. Often it's as easy as sending an email and saying, hey, I work on this. I'd really like to join your team and help contribute to that particular topic.
Listening to an interview with Dr. Laura Dressian, courtesy of astrophys.com. This is VK3EKH.
For our data, we don't typically share data via email, because our data is typically gigabytes and sometimes even terabytes in size. So most Outlook servers aren't really going to handle that particularly well. We tend to have access to external computers. So someone somewhere, say in Sydney, Tara might have some machines that the data is stored on, and then we all access and do our analysis on there, so that we don't have to be copying data all around the country or even all around the world. So that's for data and analysis. We typically don't ever try and bring things onto our own laptops if we can help it, because the data is really big, and even with the best laptops these days, they're not really equipped to handle multiple radio images that are all very large files and try and do some analysis with that. So we typically use external computing facilities. This isn't supercomputers, though sometimes we might use supercomputers. These are just smaller mini supercomputers of just a few compute nodes linked up together. We do use email to send each other plots and generally maybe more formal things where we're saying the paper is now ready, please have a read of the draft. That might be an email, but usually Slack is our typical messaging system, and that helps us because we're all in different time zones, and sometimes, you just can't respond immediately. So having those text chats really helps us collaborate without having to get up at 2 a.m. for a Zoom call. So that's how we typically have a chat, when we're just chatting to each other and going, oh, did you see this in the data? This is really interesting. What do you think about that? Do you think that looks like something real or just an artifact? That's the sort of thing that we'll chat in Slack instead.
Fantastic. Thanks, Laura. You were talking about data there. I'm hoping to interview Greg Sleep, who's the data scientist, manages the Pawsey Centre, and that sounds really fascinating.
Yes, absolutely. And Pawsey is one of our key facilities, of course, for using ASCAP. That's where we do a lot of our work and where a lot of the data is stored and processed. So it would be really great to hear that, because it's a key facility for Australian radio astronomy.
Yep. Cool. Thanks, Laura. I mentioned earlier that you've done some great FRB research on Meerkat, and you've reiterated that since the first Lorimer burst was discovered in 2007, we've now detected hundreds of FRBs, and we have some repeating FRBs. And we now have, well, thanks to some of your work, exactly where some of them are located. But the big mystery still remains, how close are we to understanding the mechanism or cause of FRBs? Are we looking at more than one mechanism? And I did see a paper yesterday in Nature which showed a correlation between FRBs and gravitational waves emanating from neutron star mergers. And we know that correlation doesn't always mean causation. What's the latest thinking on the mechanism or the cause of FRBs, Laura?
I think this is such an interesting question because I think we're a little bit closer, and I think we're always, with this kind of scientific method, when we see something and we can't do, in astronomy, we can't do a nice experiment and say, this is our hypothesis, let's test it. We just have to wait and see what we see and see how it all adds up or really subtracts, because that's typically how this works. We have a whole bunch of theories, then we see an FRB that does something in particular and we go, oh, well, that cuts out these 10 theories because they can't possibly explain what we just saw. And then we'll see another 10 FRBs and go, oh, well, that cuts out this theory, until hopefully we eventually have one theory that we weren't able to cut out. So it's more of a null hypothesis sort of thinking, and then cutting that null hypothesis out until we find the one that still remains in the end. And that's why, of course, science is always changing, because then we might have the same hypothesis that's happy for and working for 10 years, and then someone else comes in and goes, did you know, I had another thought. And this is a new theory that we have. I think there's still a big question about whether there's more than one mechanism or there's just one mechanism that is responsible for repeating and non-repeating FRBs. The best analogy, I think, is the history of GRBs, gamma ray bursts, and how that theory sort of evolved. And I think we're seeing a similar path that FRB theories are taking, that in the end, GRB people did work out that it is kind of more than one type of GRB and more than one mechanism responsible for them. And I don't think I would be surprised by that. I think it would be, they're kind of related mechanisms. They're not too extremely different, but you can't, Occam's razor is not the best way to go typically, because nature is strange. The universe does weird things. And there are usually a few ways that you can make similar flashes of light. I think we're still leaning towards magnetars. That could just be because a lot of FRB astronomers are pulsar astronomers, and we all have a bit of a soft spot for magnetars because they're very cool. But maybe a magnetar in a weird environment, magnetars just doing strange magnetar things. I think that's still the preferred theory. If you asked an FRB astronomer, you know, that's probably the one that comes up the most and is still remaining at this point. I think the paper you're talking about is probably the one by Dr. Clancy James and his student Alex. That was really exciting stuff, that they saw that there could be a link between one particular FRB and a gravitational wave. I think it's important to note here, and the authors also acknowledge that this is one of those tantalizing sort of hints. So rather than being cold, hard evidence that these two events were linked, the gravitational wave and the FRB, it's more one of those things that you go, ooh, we're going to keep an eye on that, because that could be something really, really interesting. So it's extremely exciting to see even that hint that these things might be linked together. And it definitely doesn't go against any of the theories that we have, that it's actually neutron star mergers that could be responsible for one-off FRBs. Of course, it's difficult once your neutron stars have merged to create more than one. It's like a supernova can't go off multiple times. So that does sort of lean towards the one-off rather than repeating. So it's really exciting to see these tantalizing hints, and hopefully once all the gravitational wave detectors are online and they can localize their FRBs a little bit better, that will help us to get more of a handle on whether these things truly are physically linked, rather than just that, oh, let's have a closer look because that could be really interesting and exciting. So there's still a lot of mystery going on in the world of FRBs, and that's what makes it so exciting, of course. We still haven't localized that many FRBs. It's in the tens, whereas we're getting CHIME, the Canadian H1 mapping experiment, is getting hundreds of FRBs per year, possibly thousands, because they're a little bit hush-hush. So there's still so much to find out, which is just so exciting.
Fantastic. And that's a beautiful explanation, that link between hard astrophysics and astrophysics theory, and how you're linking them via working through the null hypothesis. I looked on the FRB wiki and there were about 50 possibilities originally. Some of them have been wiped out. As you mentioned, it's a beautiful way of doing science. So just before we look at your recent move over to the University of Sydney and your research there, Can we stay on your meerkat and meertrap, and you mentioned Thundercat, that research on the localisation of FRBs? In February, I saw that you've just published a paper about FRB 2021-0405I. Can you tell us what you and your team found?
This was really exciting for me because I spent a lot of my PhD looking at one particular field that Meerkat was observing. So the Thundercat team, which is, are you ready for this acronym? The Hunt for Dynamic and Explosive Radio Transients with Meerkat. So they've definitely done a bit of cheating there to make Thundercat work. But they committed at the start of their 5 years of observing this one X-ray binary called GX339-4. They committed to observing that every week for 10 minutes. So what I did was take those images. So Dr. Lilia Tremou is the one who's working on GX339 itself, but I took those images and looked at all the other sources in the field to see how they were changing, because this is an amazing set of data every week, 10 minutes. So we really get to see how things are changing in that one patch of sky. And then excitingly, Meertrap, the other team that I'm in, that's the commensal search for FRBs, RATs, pulsars, anything that milliseconds flashes and it's gone, started piggybacking and also observing at the same time that Thundercat was observing. So now, as well as having those images every week, we're getting those Meertrap searches for things that flash at the same time. And we happened in 2021 on the 5th of April to detect a fast radio burst in that very field that I'd spent my entire PhD working on and looking at and staring at with those 10-minute observations every week. So this was really exciting for me personally, because I went, yes, that field my favorite field, it's the one that has the FRB in it. So because Thundercat was observing it, we get these nice images, and we can make images as short as 8 seconds. So even though the FRB only lasts a few milliseconds, this FRB was so bright that even in the 8-second image, we could see it. So this is the first FRB localized using Meerkat, because we happen to be working together. These two collaborations were working really well together. We have a great relationship with Thundercat and Meertrap. So because we worked together, we saw this FRB and we could actually see where it was. But interestingly, this FRB, its dispersion measure, which is a measure of the density of electrons between us and the FRB. So it's a measure of the environment between the observer and the FRB rather than a measure of a property of the FRB itself.
Yep.
That dispersion measure either puts the FRB just on the edge of our galaxy or just outside our galaxy, depending which model you use. But we think, and we're leaning towards, this is another one of those which theory will win, but we're leaning towards the FRB being coincident with this galaxy that happens to be just outside of our galaxy. So it's quite a nearby one. And all of the evidence sort of comes together to support that. So rather than having one smoking gun per se to say that it's outside of the galaxy, it's more of a circumstantial evidence situation where we've got all these little pieces that just add up to say that it's probably at that galaxy. So that just adds another one to our list of FRBs that have a known host galaxy, which looks like to us a spiral galaxy. It's a bit hard to say because there's a lot of stuff in between us and the galaxy that's kind of blocking our view. So it looks like it might be a spiral galaxy and that our FRB is sort of a little bit on the outskirts of that galaxy, which is interesting because we don't typically see magnetars on the outskirts of galaxies. So could be something interesting to see there if it is in fact linked up with that galaxy. But it's just so exciting to finally have that first localization with Meerkat, since we've been working so hard on FRBs since the start of my PhD.
Fantastic. Oh, well, it certainly is a wonderful area of research and bringing us new knowledge, new understandings, and, as you mentioned, new questions. Okay, let's look now at your move back over to the East Coast again. How did that all come about, and what's your role at the University of Sydney, and what sort of research projects are you working on right now?
Yes, the move across we can attribute to Dr. Manisha Caleb, who I also think was on your podcast probably back in 2018 at the similar time to when I was on the podcast as well. So Manisha and I were in Meertrap, and we sat back to back in the office in Manchester, and we're good friends as well as collaborators and colleagues. And this role came up, and I thought, I've only just finished my PhD. I was only about a year out from finishing my PhD, and that job that Professor Tara Murphy put out looks great, but I'm probably too junior. And I know there are some early research career scientists that are probably listening to this, and especially women. We typically don't put ourselves forward for things unless we really think we tick all the boxes. So I did fall into that trap. Even though I'm aware of that trap, I fell into it anyway, lost a little bit of confidence, didn't think that I would be right for the role because I was pretty junior. But Manisha said, no, Laura, really, she's at Sydney as well. She said, no, really, you should apply for this because I think you're a good candidate and just go for it. Why not give it a shot? Yep. So having that extra encouragement pushed me over the edge, and I went, fine, I'll do it. It was also a little bit hard because I have to say I absolutely loved working with CSIRO and Perth. So this is a step up in my career, which is why I ended up taking it. But it was definitely not because I didn't love living in Perth or working with the team at CSIRO. I still have ties with them, and I'll probably join up as an affiliate for the CSIRO as well because I really did enjoy my time over there.
Yep.
So I really applied because Manisha said, go for it. And now I'm a postdoctoral researcher. So Professor Tara Murphy recently took up the role of head of school of physics at the University of Sydney. So she has to work out how to balance her role as a science lead and a team lead, as well as the head of physics. So my role as a postdoc is to keep doing my research and doing lots of fun, exciting things with VAST and ASCAP, but also to help her keep on track with her students and make sure that team meetings still run and that there's someone there for anyone to sort of touch base with and keep things going on track for her science as well. So it's a really great leadership role for me to take on as well. So I'm really excited about the science as well as taking that extra step as an early career researcher to take that leadership role on as well. So I'm excited to be over here, to be closer to my family who are all in Melbourne, but also to really take that next step in my career.
Fantastic. And from our point of view at Astrophys, you were certainly ticking all the boxes, Laura. Last time we spoke, you mentioned that you've made outreach one of your priorities, and I love hearing the excitement in your voice when you're talking about your research. What about research? And you want to bring to the public a wider understanding of science and how scientists work. You've explained that beautifully just before when you were talking about the null hypothesis. Are you still involved in outreach projects?
I am. I'm really excited. You mentioned at the very start that I was selected as a superstar of STEM for this year and next year. So for those of you who don't know, the Superstars of STEM is a program, a 2-year program run by Science and Technology Australia. And it's where 60 women and gender non-binary people around Australia are chosen every 2 years to be part of this program that's main purpose is to build the profile of women in science, in the media in particular. So at the moment, basically, if you see a scientist come onto the project or on ABC radio, they're typically a man. So the purpose of the Superstars of STEM is to get women into those media spots instead, just so that we can really show people and, of course, young women and girls and young boys and men as well, that you don't have to just be a man to be a scientist, because sometimes that's sort of what it feels like. And, of course, that's not to say that I don't have loads of wonderful male colleagues, and there are lots of excellent science communicators of all types out there. But it is key that we do show that you can be anyone and be a scientist. And I think when I go into schools, which is another aspect of the Superstars of STEM, is to go into schools on Zoom or in person and just show the work that we do, so that really opens the minds of kids. But I just find that it's so important to really show that we're people as well. And I think most people don't think about it this way, but if you go to your local shopping centre, you're probably walking past someone with a PhD every time you go to your local shopping centre, and you wouldn't know, because just like in all careers, whether you're an accountant or a hairdresser or a plumber, most people just look like everybody else, and we all have all of our other things that we do. I sew my own clothes, and I also love to go for a nice walk along the Roselle Bay foreshore near Sydney. So I think that's one of the key things that I really like to do it when I do science communication, is show that we're just like everybody. But I also have to say that I absolutely love doing anything like having a chat with you, Brendan, or going into schools or going to an outreach event. It really invigorates my enthusiasm for what I do, because I do love what I do. But when you speak to people who are truly wowed, because we forget we're in our own little bubble. Everyone that I work with is the leading expert in the world on what they do.
Yep.
And so you end up in this bubble where we're all doing something really amazing. So it's only when we get to really share that I go, yes, you're right. This is truly amazing that I get to do this every day. So it really reinvigorates me, as well as hopefully spreading the word of how great science is and just the options. So if one kid sees me and then realizes that there are more options open for them, whether it's astronomy or something else, then my job is done.
Exactly. And putting that diversity front and centre is really important. It's important to us here at Astrophys. We've got a diversity policy, and we try and make sure that we represent the community as much as possible. Our guests are really diverse, and it's very exciting for me here as well. I can hear the excitement in your voice. Now, right now might be a good time to ask how the current worldwide COVID-19 crisis has impacted on your work. You alluded to it earlier, and we always hope that it's over, but it keeps on keeping on. I'm still wearing a mask when I go into crowded indoor situations. I hope your diplomat twin sister and your folks down in Melbourne are still all okay. What are your personal and professional reflections on the COVID-19 pandemic, Laura?
Oof, I think like a lot of people, I probably have a lot of thoughts on this. I'm with you as well. On public transport and in crowded indoor spaces, I'm still sticking my N95 on. It's a small change I can make to even just avoid having the common cold. I think during COVID, we all realized how annoying that was when you have a cold too. So even just those little things, trying to miss the usual bugs is something that I'm very happily on board with. I think it's really interesting to me, and as I moved into different states in Australia, to reflect on how the COVID situation impacted all of us individually in a very different way. And I think that's something that we have to be really aware of and understanding of when we interact with people. Because I was in the UK when the pandemic started. I'd actually just got back a couple of weeks earlier from a trip to Cape Town in South Africa, and that was when they were still doing the temperature testing, but we all definitely hadn't sunk in how serious the situation was. So we then went into lockdown in the UK, and about 3 months after we went into lockdown, I sort of had this epiphany that I didn't need to be staying on my own in an apartment in the UK, and I could go home. So I did spend the rest of the pandemic in Melbourne living with my parents, and I'm very lucky. I'm one of the people who gets on very well with my parents, so I was happy to be there with our family dogs, close to the Yarra Valley region where you could go for a lovely walk, and it was a little bit of a different situation for me. But it was the last 18 months of my PhD working from the other side of the country to my supervisor and all my colleagues. We were all, sitting in our homes or apartments on our own, but it was a bit different being in a totally different time zone without having that ability to say, hey, can you help me with this? Because they were asleep. So I was lucky that it was the end of my PhD, because I'd already sort of established my research abilities, and I was able to independently push myself to keep working. And I can thank my parents and my family as well for their support in that. But then even moving to Perth was like going to a whole nother world, because they'd barely been touched by the pandemic compared to Melbourne, where we had a 5-kilometre radius and a curfew. So every time I've moved, it's like I'm an alien in a different land trying to work out how the world has been. I think in Perth it was most interesting because people didn't stop over there, whereas a lot of us over on the East Coast, all of our hobbies sort of fizzled out. We couldn't go and play tennis on the weekend or I don't know, go to roller derby or whatever your chosen sport is. So our lives stopped and we kind of took a step back and reevaluated the things that we really wanted to spend our time on. Whereas in Perth, people were going, oh, I've got this on tonight and I've got that on tomorrow. And I sort of went, wait, what? You don't have hobbies. We don't do that. So it was very, very strange to go to a place where they hadn't, where we'd been so impacted in Melbourne, to go somewhere where they'd barely been touched. So it was tricky. So my twin sister is actually the orthopedic surgeon. It's my older sister who's the diplomat. She was in the US at the start of the pandemic. So that was tricky. And even coming home for her was a bit harder than the UK. Luckily, my sister, who's a surgeon, I think she's only had COVID once somehow. So she's been very careful about masking and things like that, despite being in a hospital environment every day. But it was tough, just for her, the not knowing of whether, the next day she was going to be called into a COVID ward or something like that, or into emergency, rather than fixing people's broken hips and things like that. So it's definitely, everyone's experience has been different. And I think that's the main thing. As far as professionally, it's mainly affected conferences and how we come together as scientists. I think some people have been more flexible and aware of how the impacts of that, and how some of the things we should keep going from an accessibility perspective. People being able to join, whether they have kids or caring responsibilities, people who have disabilities who might find travel challenging. I think being able to do hybrid and actually trying, rather than just going, oh, we'll stick it up on Zoom, but helping to actually make those online experiences valuable and useful for networking. So I really appreciate the people who are working in that space and actually trying to make these things better and adapting, rather than just going, oh, we'll just go back to the old ways now, which was better for a lot of people to go in person, but for some people it wasn't. So I don't think it hurts us to really think about how we're going to move forward, rather than just defaulting back to the old way.
This is VK3EKH, the official station of the Astronomical Society of Victoria, with a replay of an interview with Dr. Laura Dressen, courtesy of astrophys.com. And we've only just got a few more minutes to go on this one.
Exactly, and we've got more choices now. So there have been some good things that have come out of it. For me, the big thing for me is my admiration or adoration of medical professionals. It's limitless. I cannot thank our medical professionals enough, the way they've carried us through this pandemic. Please pass on to your surgeon sister. Thanks from all our audience as well. Let's now bring our listeners up to date with the nitty-gritty of your current work. Could you talk us through some details of a particular problem that you're working on now that's driving you crazy, or astonishingly exciting, or perhaps both, Laura?
I think a lot of what we do is a bit of both of those things. That's often the problems that come out the most, are the ones that are annoying us. So we spend a lot of time trying to fix the problem because it's just killing us. So I mentioned a bit that I'm working on radio stars now. So what that means is, at the moment, I'm trying to find stars that emit radio light. So this is important because, as I mentioned earlier, we haven't really done too much work. There have been a few people who have done some excellent work in the interim, but really the major effort on radio stars was in the 80s or 90s. And then a couple of people managed to keep it going in between, and now we've brought it back. Other people like Dr. Joe Callingham, who's in the Netherlands at the moment, has also been a big part of that, working with LOFAR. But one of the key problems is that if you look up at the night sky, hopefully everyone has at least a halfway decent view of the night sky where they are, you can see a whole lot of dots. And we know that almost every single one of those dots is a star. If we took a picture of the same patch of sky with our radio telescope, we also see a lot of dots, but we know that almost all of those dots are, in fact, radio galaxies, not stars in our own galaxy.
Yep.
So that means if I find a star, an optical star, at a certain spot on the sky, and there happens to also be a radio spot at that same position, chances are very high that that's just a galaxy hiding behind a star. It's difficult, I should say, to prove that the radio light is truly coming from the star rather than just an active galactic nucleus hiding behind the star. So that's one of the things that's driving me crazy, but that also leads to some creativity in how to prove that the radio light is truly coming from the star. So one of the ways I did this, that is a paper that will be out soon. I just resubmitted my response to the referee 2 days ago, so that should be out soon, fingers crossed.
Yep.
Is to use proper motion. So when we look at those stars, we can't see it, but most of them are moving. So if you imagine someone running past you and you take a photo, wait a few seconds and take another photo, in those two photos, the person will be in two different spots.
Yep.
But the trees and houses behind them will be in the same spot because they don't move. And it's similar. Our stars that are close by in our galaxy are like the person running. They move across the sky. But other galaxies in the far distance are like the houses and trees in the background. Whether we wait 30 years or 100 years, they should stay in the same spot on the sky while the stars are moving. So what I did is I took some radio images that were taken about 30 years ago with the first survey, which is a bit of an annoying name because it makes it hard to say. The first survey was the first radio survey that I used. So thanks for that naming convention. So that's a very large array survey. And the more recent ASCAP sky surveys, the Rapid ASCAP Continuum Survey and the VLA Sky Survey, VLAS.
Yep.
And I was looking for things that have moved from 30 years ago. Are they in a different spot now? And I found a few stars that way. So that's a way to prove that the radio light that we see is coming from the star itself. And there are a few different ways. So that's the thing that's driving me crazy and is also exciting because it's a fun problem to try and work around. I think that leads to lots of creativity for all of us looking for stars.
Ah, that's beautiful science, Laura, and your explanation has a clarity to it that's sparkling. Thank you. Is there anything else that we should watch out for in the near future? I'll certainly catch your paper when it comes out. What are you keeping your eye on?
I think one of the most exciting things and something that a few of us in the radio star space are working on is trying to see whether we can find exoplanets by using radio observations. So for those of you who are across JWST and Kepler and all that sort of thing, we have lots of good ways to find other planets. So an exoplanet is a planet that's orbiting a star that's not our sun. So all those stars out there, loads of them have planets and we have to find ways to see them. So there are lots of optical missions. TESS, the Transiting Exoplanet Survey Satellite. I always mix up what the S's stand for. It's something like that. That was the successor to Kepler, is finding planets all the time.
Yep.
But we're trying to see if we can see any of those hints that there's a planet there in the radio. So that's something to keep an eye out for, that a few of us are working on. No one's done it definitively yet, but we're trying, and it could be really fun.
It is fun. And I just saw last week JWST had looked at, I think it was the innermost TRAPPIST exoplanet, and they said, no, you could not live on it. It's not Earth 2.0.
Yes, unfortunately, that's probably going to happen a lot. I think that we don't realize how lucky we are that Earth even existed in the first place, because there's not many other places where we could have evolved the way that we did.
Exactly. Okay. Look, our time's just about up, Laura. Thank you so much, Dr. Laura Dreesen, on behalf of all of our listeners, and especially from me. I'm learning so much by osmosis here. It's been really fantastic to be speaking with you again, and thank you especially for your time. I know the pressures that exist in departments in universities. I really understand how difficult it must be to squeeze in all the demands that you have on your time. Now, for listeners, Laura's website is at astrolaura.com. On social media, you'll find Laura. She's at AstrolauraD on Twitter. And her non-astro work, artistic and construction things, are on Etsy at Umigumi. And you mentioned your dog earlier. Her Whippet dog is on Instagram. It's astro.the.whippy. Do you want to talk about Whippy?
I can just say that he's a Whippet. He's with my parents. because he's got anxiety. So like many of us, he struggles a little bit with mental health. So he stays there with my parents. But Astro is a reference to Astro Boy, the old school cartoon TV show.
Yep.
And also Astro from the Jetsons. So astronomy, but also more of an old school cartoon dog.
Okay, a big shout out to Astro the Whippy on Insta. Okay, good luck with all your projects, Laura, and with your next adventures. We'll have to have you back on the show again in another few years. Thank you so much, Laura.
It's my absolute pleasure, Brendan. I always love having a chat with you, and I think we could put in our calendars 2028. We can have another chat.
Thanks, Laura. Have a great day.
You too. Thanks, Brendan. See you later.
All right. That was a interview there with Dr. Laura Dresian, and that went a little bit over time for us, but just bring up my level here a bit. And so I hope you enjoyed that interview. There's a swag of those interviews that I'd like to throw up here on the Friday night session once in a while, and it's it's just because I was running late that I thought I'd squeeze something like that in tonight. But anyway, there it is. All right, now I'll go straight into spaceweather.com. And let me see, bring that up there. All right. And I've got that to go. So, okay, there's the sun. All right, the solar wind is currently at 481.8 kilometres a second at a density of 1.04 protons per cubic centimetre. The current disk of the sun, which I've got up on screen at the moment, has several sunspots on the side facing Earth right now as we speak. 1, 2, 3, 4, 5, 6. I can count there. And the current sunspot number is 121, with the radio sun at 10.7 centimetres is currently 164 solar flux units. 164 solar flux units. The K index, planetary K index, KP is equal to 2.00, which is considered quiet. The 24-hour max KP figure is 3.00, which is still considered quiet. Okay. There's a glancing blow CME possible today. NOAA forecasters say that a CME might pass near Earth or maybe deliver a glancing blow today, May 26. It was hurled into space 4 days ago by an M1.9 class flare from sunspot complex AR3311, which you can see on the disk there. And at most, a minor G1 class geomagnetic storms could result from the close encounter. Now, there's another interesting image here from spaceweather.com as well. This really quite amazing close-up shot of a sunspot into the dark heart of a sunspot. It's called. Sunspots may not be as dark as we thought. In May 19th press release, the National Science Foundation released a high-resolution images from Daniel K. Can't pronounce that surname. Solar telescope. And they show bright dots speckling the core of sunspot AR3053, which you can see in the image there on YouTube and TV. These are known as umbral dots. Umbral, U-M-B-R-A-L, umbral dots, incandescent balls of plasma rising and falling in otherwise dark heart of the sunspot. Researchers believe that they are turbulent convection cells which dredge up heat from 1,000 kilometres below. The same kind of motions can be seen in a pan of water boiling on a hot stove. Yes, I've observed that. The Daniel K. Wait, how do you pronounce that? Ninouye. Ninouye? I don't know. The Daniel K. Ninouye Solar Telescope is a 4-meter solar telescope on the island of Maui, Hawaii. And it's currently the largest solar telescope in the world, with the unique ability to photograph the sun in unprecedented detail. Studying the fine structure of sunspot cores may help predict when they will flare. So yeah, there's a really interesting shot there of looking right into the heart of a sunspot roast. Most interesting indeed. Now, this is another interesting thing. So I'm going over time, ladies and gentlemen. I apologise for that. But this is another interesting thing that's just come through. A supernova in London. A week after it exploded in the spiral arm of the Pinwheel Galaxy, or Messier object M101, a new supernova. Hang on, I'll bring up, there is a picture here, or at least a shot. There it is. New supernova SN 2023 IXF has finally peaked in brightness at magnitude +11. It turns out that that's bright enough to see from downtown London. I don't know why it's downtown London. Anyway, the supernova was easily visible in the author's telescope, despite the bright lights of the city, reports Terence, what's his name? He says, I had great views of the supernova through my EV scope Equinox 2, he says. SN 2023 IXF is a Type 2 supernova caused by the core collapse of a massive star. A shockwave escaped the dying star on May 19, Earth time, creating a 15th magnitude fireball first noticed by a Japanese fellow in Japan. The expanding fireball has since brightened to 40-fold to magnitude +11, and that's too dim to see with the unaided eye. But as the photographer photo shows, it is an easy target for backyard telescopes, even in urban areas. The picture on the screen right now shows you approximately where this supernova is in regards to the Pinwheel Galaxy. It's got two red lines on either side of the supernova to pinpoint it. So if you've got a telescope, look for the Pinwheel Galaxy. I'm not sure. To be honest, I'm not sure if the Pinwheel Galaxy is also a southern sky, a southern hemisphere object. I think it is. If you've got a star chart program, like Stellarium, and I'll go and check it out later. Actually, Pinwheel might actually rise in the southern hemisphere at some point, but I'm not sure exactly when and where. Nevertheless, we have a supernova in the skies. How rare is that? But there it is. All right, not much in the way of aurora at the moment over Antarctica. It's very, very vague as we speak, and I didn't capture it, but it doesn't matter. It's very, very vague, so there's hardly any aurora to speak of. Or write home about. All right, I think that's about it. Near-Earth hazardous asteroids, potentially hazardous asteroids. As of May 26, 2023, there's 2,335 potentially hazardous asteroids that we have to worry about. Okay, on that note, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. We've gone over time tonight, sorry about that, but I figured the interview there with Laura was an interesting one to run, courtesy of astrophiz.com. I would highly recommend that you visit the website, www.astrophiz.com, and look at all these 171 interviews. Listen to them at least. Most entertaining stuff. All right, on that note, we shall pick up any stations that are still awake on 80 metres for a quick callback and to see who there might be. I'll just get a new page here. And is this pen working? Yes, it is. Okay. All right. So this is get the camera on me again. vMix is down the bottom here. Oops. Stand by, people. There it is. Just looking for my mouse. Camera and action. All right. And bring that up a little bit. So this is VK3EKH, having a quick listen on 80 metres for any stations wishing to check in. Okay, and of course my pen didn't work, so I had to scribble hard into the paper. VK3JR, VK3BDA. I can only tell that it's you because I can see the impression in the paper. The pen just decided to give out on that. VK3ADX, I think it was, Alpha Delta X-ray. VK3SPX, VK3ACZ, VK3 Delta X-ray, VK7JAH. Did I get everybody right? And is there anybody else? Okay, VK3TJS. All right, to the top of the list. Good evening, Frank. VK3JR, VK3EKH. Yep, go ahead.
BBC website. Most interesting, and I had an interview with one of the first people to discover it. He's an amateur astronomer in Holland. Most interesting indeed. Thanks for the spaceweather.com information. I always enjoy that. Find it very instructive. And there's no missions tonight. And your 160 metre AM signal is way stronger than it used to be. That's enough from me. Thanks for doing it. VK3EKH, VK3JR. VK3JR, VK3EKH returning, and mucking around with all sorts of controls here in the shack because I'm trying to get a feed, an audio feed from 80 metres over the internet and TV, which I've just managed to get working. So people can hear the other side of the story. Thanks, Frank. Good signal from you here, and I'm not transmitting on 160 metres. The AM transmitter is downstairs at the moment, and until I can remotely run some cables through the roof or the floor here downstairs, so I can control things from downstairs. Or from up here, more like it. I'll get back. Well, actually, it's an antenna problem. If anything, the antenna is tuned for 1825, and it is forbidden to operate 1825 after the sunset. So I need to get something working at the high end of the band. That's another problem. But no AM on 160 at the moment, Frank. And but we are getting there. And yes, the supernova, it's interesting to, I'll see if I can find out more information about that and find out whether the Pinwheel Galaxy is visible here in this part of the sky. Actually, Graham might know a bit more about that. All right, Croston Graham, VK3BDA, the official station of the Bendigo District Astronomical Society, which is a section of the ASV. Take it away, Gray.
Yeah, thanks very much, Clint. VK3EKH, VK3BDA, as Clint said, the call sign of the Bendigo District Astronomical section of the ASV. And really, really good broadcast, very interesting, and Dr. Dreesen was fantastic to listen to. She's doing some really interesting stuff, and the YouTube video was great. Actually, I started off listening to and watching the YouTube broadcast, and then come up to the radio room and switched on the radio, and the audio sounded really good on the 7300 here, this end, Clint. Pretty much like a broadcast station. Dr. Dreesen's audio came out really, really good. So, the Bendigo section's been motoring along, and we've been having meetings at either Discovery Centre or on Zoom, and the next month actually will be a face-to-face for a get-together and a meal. So, at a local pub. So that's what we've been doing here in Bendigo with the Bendigo section, and also venturing out at times to the dark sky side, but I haven't actually been out there for a while myself, but I know some of our members have actually been out there. So we've been doing sidewalk astronomy every month at Discovery Centre. We advertise that in the media and on Facebook, and get some people interested going along and having a look through the telescopes there at Discovery Centre. So it's great that we've got a really good relationship with our local Discovery Centre here in Bendigo, and they're very supportive of what the ASV Bendigo section gets up to, and vice versa. We are very supportive of what they do, and they've had a recent planetarium upgrade as well. So they're kicking along really well too, which is great to see. Not much else to report this end. I've been quite busy with our local radio club, the Bendigo Amateur Radio Electronics Club, and I'll look forward to our next Bendigo Section ASV meeting. And also, we have them on Zoom. If anyone's interested in joining us on Zoom, they're more than welcome. For ASV members, you can actually go to the Zoom section of the ASV site, and also the Bendigo section, and find out more information on when the meetings are. When we have Zoom meetings, we are able to see the amazing astrophotographs of astrophotography of some of their members, and it's quite amazing what they present on Zoom, and so very impressive to see what they've been up to with their cameras. Back to you there, Clint, and thanks for the broadcast. VK3EKH, VK3BDA, Bendigo.
Yeah, thanks, Graham. VK3BDA, Bendigo, VK3EKH replying. Very good. As usual, you're up to all sorts of things up there in Bendigo. You're very proactive with a lot of the astronomy side of things, and not to mention the radio activities as well, and of course your community radio station work that you do too. So very good, Graham. It's you do very well indeed. And thanks for the report too. Look, the ICOM 756 Pro 3 does produce some very nice audio, and if the audio source is also of reasonable quality, then I should be able to faithfully reproduce that on a sideband signal. Of course, the female voice comes through very, very clear as well. So I guess it's the distinctive quality there too. But nevertheless, thanks, Graham. Now I think it was VK3 Alpha Delta X-ray, VK3 ADX. I can't remember your name. VK3 ADX, VK3 EKH.
VK3 EKH, VK3 Alpha Delta X-ray. Thanks for the broadcast. Great signals all around. You're 28 times to call out. The hand is moved. Thanks for the broadcast. Tonight. VK38, VK8, VK380.
Thanks, Merv. VK380X, VK3EKH. I think you're at Ballarat Way. And thanks very much, Merv, for the fine comment there. You're just on this strength 9 here, not super strong, but you're just on the strength 9 here in Narre South. Thanks, Merv. Good to hear you. Thanks very much. Steve, not too far away from Ballarat. VK3SBX, VK3EKH.
VK3EKH, this is VK3SBX. Yeah, a little bit near Ballarat, near Barringup actually, near Malden. Yes, good broadcast, Clint. Yes, Laura Dresson is an impressive young woman, I've got to say. What a amazing accomplishment for someone so young. So it's very interesting. I like that photo you had of the sunspot. That's an astounding photograph of the sunspot with those rather strange blobby bits. I just haven't seen a sunspot like that before. That was a real, yes. And yes, M101. I have actually imaged M101 before, but right now it's below the horizon. At least it is to me. It's just a few degrees below the horizon, so I think we're out of luck at the moment, unless you're in a radically different place compared to me, which is unlikely, I think. Anyway, yeah, no worries. Thanks very much. And like Graham, I was listening on my 7300 too, and I thought the signal, particularly Laura's voice on the 7300, was as good as the YouTube, which was quite amazing. Very, very clear indeed. Okay, thanks, Clint. VK3EKH, VK3SBX.
Good on you, Steve. VK3SBX, VK3EKH returning. Very good. Thank you for the reports there. Yeah, if I can get my 160 meter AM transmissions up and running, pardon me, the audio there should sound quite good on the AM side of things too. So, but certainly the sound that I hear through ATV is also pretty crystal clear, and which would be the same as what you'd hear on YouTube too. It all comes from the same source, and I'm glad to say that the stream has held in for the whole hour so far. It hasn't dropped out. Thank goodness for that. Thanks, Steve. And yeah, look, the one thing that's interesting is that most of the interviews that Brendan O'Brien has got on Astrophys are with the female scientists. I think the majority of the interviews there are with female scientists that or students that are doing research in astronomy, physics, and how he sources the ladies, I don't know, but it's certainly great that we're able to get, or he's able to get the ladies online and to talk to them about their interests and studies. So I do recommend astrophys.com to listen to these the interviews that he's got there. Okay, it's across to Peter, VK3ACZ, VK3EKH.
VK3EKH, VK3ACZ. Good evening, Clint. Thank you for the broadcast. I'm kind of excited by the thought of a supernova in the sky again. The last one I remember was in the Magellanic Clouds, one of them in 1987. So it's been a while. You're probably aware it's a noisy band tonight. The QRN is off the northern New South Wales coast out in Tasman. But I scrolled around the Kiwi SDRs, and I thought I'd listen to you on the North and South Islanders ZL. Just to let you know, broadcast was well received over the north. You were 10 to 20 dB over it on all the SDRs I checked. On the South Island, you're only 7 to 8. So no drama, of course. It sounded really good over there. So great propagation tonight. And thanks for the broadcast as always. VK3EKH in the group, VK3ACZ.
That's fantastic, Peter. Thanks very much for that report. I know that you regularly do give me the feedback on the SDR signal, so that's really most interesting, isn't it? How far we're getting out. I do run the linear. I'm not sure if you've seen any of the video side of the broadcast, but the linear over the back of me there, it's running up to 400 watts into an inverted V, and it's actually I'm fairly impressed with how far the signal is going. Although, mind you, it's now coming into winter. It is the best time of the year for 80 metre propagation, really. And of course, solar flare activity is contributing to that activity too, I suppose. Although I'm not too sure at night time, but anyway, there it is. Thanks, Peter. Good on you, and we do appreciate the report. Greg, down at Warren Nobel, VK3 Delta X-ray, VK3 EKH.
Yeah, good on you, Clint. VK3 EKH for the net tonight. Good on you, mate. You've done a great job, as you do each week, and we'll appreciate what you are doing there, Clint, because it is time-consuming and all that. So good on you, mate. And good evening there to Peter, VK3ACZ. I heard him check in earlier, but got a lot of rain static here at the moment. I don't know if the band's changing, but signals have dropped back a little bit. Anyway, it was all good, Clint. Enjoyed the net there tonight, and it was all very interesting, mate. And I'll be around again next week. And have a good weekend there, Clint. VK3 EKH, VK3 Delta X-ray, Greg in Warrnambool.
Thanks, Greg. VK3 Delta X-ray, VK3 EKH replying. Very good. Thanks, Greg, for all fine comments. Excellent stuff. And I'm just glad all you guys hung in there for the extra extended broadcast session tonight. Usually when I do play the interviews that Brendan does, I edit it down to just the interview, so I knock off the intro and anything else that might be after that, so it's just the interview. But tonight's interview did actually go for about 51 minutes, so my preamble caused that to go over time. Anyway, that's another story. Thanks, Greg. Yeah, the bench doesn't sound too bad. It's not. There's not a whole lot of lightning crashes I can hear. It seems to be not doing too bad at the moment. Martin, VK7JAH, not your usual strength that I've had you in the last few weeks. You're back to a kind of a normal signal strength, from what I can tell. Across to you anyway. VK7JAH, VK3 EKH. You always catch me when you do that, because I expect to hear call signs, and you suddenly just stop. Anyway, no worries, Martin. Yeah, your signal's just in there. You can hear yourself on YouTube. As soon as I stop sending data to the internet, you can catch up a replay because I've got the audio directly patched through, so it'll all be available to hear on the YouTube when I stop sending. Thanks, Martin, and note that you got a bit of noise down there as well. Alrighty, it's Jack, VK3TJS Shepparton. G'day, mate, VK3EKH.
Yeah, VK3EKH. This is VK3TJS. I'm back up at the Mignon, so it should be a bit better. Good evening to you, Clint, and good evening to everyone that's joined in. What a list tonight. I was listening with intent of the broadcast, and it was quite a good transmission for most of the time. There's a couple of things, a couple of times when you're playing recording, the signal strength dropped a bit, but it was still very, very readable. Mostly it was around about 20 over as usual here in Shepparton. And very cold Shepparton at the moment. Yeah, we've had a bit of rain. We've had before that we had frost, so it was first frost for the year. And around about probably 5 degrees in the mornings at the moment, like probably tomorrow or so. Thanks for the broadcast. It was great to listen to you, and I hope you have a good weekend, and everyone else as well. VK3KH, this is VK3TJS.
Thanks, Jack. VK3TJS, VK3EKH returning. Very good. You're about almost clicking on 20 over 9. 5 and 9 plus 20. So, and once you turn your, I'm not sure what you did, whether it was you turned on the amp there or not, but your signal definitely came up much more readable. So, very good. Thanks, Jack. And it's as it was observed by Steve VK3SPX when Laura was talking, the signal was up at least 10 dB more, and then when Brendan was talking, the signal suddenly took a dive. So it just goes to show the power of the female voice, I suppose. Anyway, thanks, Jack. Thanks very much for calling in. I appreciate that. Is there any other stations wishing to check in? VK3EKH listening. Okay, thanks very much, everybody. It's 9.8 degrees here at Narre Warren. 9.8 degrees, sure to get lower by the morning. So we are definitely coming into a cold winter for sure, I think. So, thanks everybody that came up on Discord. Kim, VK5FUSE, David, VK3KDM, and Richard, VK3VRS, Cassiopeia, or Nebs, Martin, VK7JAH, and I think there's a little bit more there. Graham, of course, GRK, and I think that's about it, all I can see there. Remus, cheers to you there, Remus, if you're still listening, watching, and I think that's about it. Yep. We had a very interesting meteor burn up in the atmosphere in Queensland early this week. I didn't put the footage up on vMix to show, but I think we all saw it. If you didn't see it, it's on the internet. But it was a pretty bright meteor burn, and I believe there was a sound associated with the meteor burning up. Not that it was recorded, unfortunately, but not that I'm aware of, at least. But there should be some fragments that hit the ground, so I'm sort of keen to find out whether any meteor hunters have found any debris in the area. Be interesting to follow up on that. Not many people sent emails tonight. Only Stephen VK3HK and Mr. SPX, so 3SPX. So that's it. All right, thanks very much, everybody. We've gone over time. Cheers, take care, look after yourselves, stay warm, and we'll be back next week to do it all again. And there was something else I was going to say, but I can't remember. All right, this is VK3EKH on behalf of the Astronomical Society of Victoria, concluding transmissions for tonight on 3541. And the ATV repeater, VK3RTV1, and the YouTube stream. Cheers, everyone. Take care. Look after yourselves. VK3EKH.
Good on you, Clint. I think winter's actually started early.
I think so too, actually.
Cheers, mate.
I'm not sure if somebody called me then.
VK3GRK, VK3SPX.
Okay.
Yeah, VK3SPX, hi there, Steve. Yeah, VK3GRK.
Yeah, hi Graham. Just in case someone else wants to have a chat here, do you want to maybe move to 3655 or something like that for a quick chat?
Yeah, roger that. I can. I'm also going to put VAR on now, 2 VAR AC on probably 20 metres. Would you like to QSI 3655?
I just thought we'd have a quick chat first, that's all.
Roger that. VK3GRK, QSYing 3.655. See you there.
VK3SPX, likewise.